guys, my name is JJ Khoza. On this lecture, I am doing inequalities, just inequalities. And this is going to be a short lecture, maybe about 15 minutes. This lecture is lecture number 4 on the series of equation. The series of equation, we've got a series, playlist series. First, when we talk about inequalities, we are talking about two things: a greater than sign and a less than sign. So I'm gonna show you. We are talking about this and that. We are also talking about this and that. These are two things that we're talking about. We dealt with equations. Equations have got this. This is an equation. Equation. This is an equation. These are inequalities. Is the topic for this lecture. Okay. So I want to show you how do we work with these signs. First of all, we know that a greater than is denoted as the following. So when we talk about greater than, we talk about this sign. On the number line, if we have a number line 0, 1, 2, and we want to represent it, if x is greater than 2, this does not look like a 2, it looks like a z or a z, as the Americans call it. 2. So we are going to have a dot, but it's a small circle. Greater than, the line is going to show towards the right hand side, because the bigger numbers on the number line, they go towards the right hand side. Okay. And then smaller than, this is it. If x is smaller than 0, it will start here and go towards the left. Here x is smaller than 0. Here x is greater than 0. Right. We also have a greater or equal to. Greater or equal to. This is the sign. greater or equal to, if x is greater or equal to 1, here we have 0, we have 1, we have 2, here we have -1. Sorry. If x is greater or equal to 0, it means we have a dot, a solid dot. Okay, let me make it bigger. Yeah. Yeah, there. Okay. We have a solid dot here. This tells us we are going towards the right, and x is greater or equal to 1. Alright? And smaller or equal to if x is less or equal to -1. We are going this way. Here x is less or equal to 1. Okay, I think this is clear. It looks clumsy, but you can see. We are then able to represent this in a form of like a band, you know. There's an upper bound and a lower bound. So you can imagine it like a band. Like a confidence interval band, you know. So yeah, to state it properly, it's a interval. We can show an interval. When we show an interval, imagine having this condition where x is less than 2, x greater than -1. Let us plot it. 0, 1, 2, 3, -1, -2, -3. X is less than 2. Less than, it's a ring, a small ring. And we go to -1, we put a ring. X less than 2, we go towards the right hand side. Okay. And x greater than -1, we go towards, this is the left hand side, and we go towards the right hand side. So this is what we are having. This is what you're going to see. Similarly, if you can have x less or equal to 3 and x greater or equal to -3, you're going to have this. So it's here. Let me use a red line so that you can see. Greater or equal to, we have solid dots. Remember that. So I'm joining there. This is the interval. This is what you need to know. It is very important. And then we need to be able to specify the domain. All right. Or a set. Let me talk about a set. So we do a set builder. A set builder. A set builder and a notation builder. A notation, interval notation, sorry. Let me write this in this way so that it can be simpler to work with. I'm going to have an interval notation interval notation. The interval notation, it will specify x element of a particular interval. If you are using a greater than, or a less than sign, you are going to use a specific set of brackets. We have two types of brackets. We have a square bracket. We have a square bracket, and we have a curved bracket. The curved bracket represents, okay, I'm going to write it in signs. This one represents two signs, greater or less, these brackets. And the square brackets represents greater or equal to, less or equal to. So for instance, you can specify, what can I specify? Let me say I have x element -2 up to 1. So the graph here (0, -1, -2, 1, 2. This sign greater or equal to, the greater or equal to, because this is on the greater or equal to, we have a solid line. On the 1, oh, I made a mistake here. Let me just correct this bracket. I did not want this one, I wanted this. Oh, this is what I wanted. So here we're going to have a ring, and we're connecting these lines. It means here we have x greater or equal to -2, and we have x less than 1. This is what we are having. Okay, now to put it in an interval, I'm going to create an interval. So the interval is going to be x less than 1, x greater or equal to -2. Can you see? This is it. It's clean. This is from -2 up to -1, up to +1. So we're going rightward, towards the right hand direction. This is it. This is what you need to know. The second part is that when you solve equations, let us say for instance maybe you have -x minus 12 or plus 12 less or equal to 0. Okay, therefore you have -x less or equals to -12. You divide by -1, you divide by -1, you end up with what happened here. When you divide by a negative sign, when dividing by a negative, the inequality sign changes. Faces opposite direction. That's it. Okay. Here I wanted to show you that this is an interval notation. This one is a set builder notation. So let me just take these figures and show you these differences. An interval notation is x, element of -2 from -2 to 1. Where we specify that x is an element of real number, always, all the time. We also have a set builder. A set builder. How do you see a set builder? We have braces. X such that x is less than 1, greater or equal to -2, we close the braces. This is how you can specify what else can we do here. We are done. Are we done? Or you want us to do quadratic inequalities? On the quadratic inequalities, you are only solving for x, but let us say you find that there is a fraction. There is a fraction, and the fraction is represented by, let me just write an example here. Maybe you have here we have a critical value here on this one, a critical value, critical value. Why do we say there is a critical value? We need to prevent this from becoming undefined. What is it that can make this expression on the left hand side become undefined? Is when it is divided by 0. So how do you see a critical value? We have x minus 3 equal to 0. X is equals to 3. This is a critical value. If x is equal to 3, then the left hand side is no longer greater or equal to 0. It's no longer an inequality. The inequality property would have been violated. You must make sure you understand this critical value. These other things are simple. It's just what we've done is what I've already explained. So on top here you are going to factorize and find your factors. This is what you must understand. Critical values. And then the rest is just simple things. We've gotten to a stage whereby we've done a lot of things. I've given you sufficient background to enable to navigate in the algebra world. So now you are able to tell. And you must always make sure that the statement is always fulfilled. For instance, you cannot have maybe x squared plus 1 being less than 0. It means this is less than 0. What could it be? Because these equations, They have a meaning. They have a meaning. A square of a number can never be 0. They have a meaning. So in this case, there is no solution. No solution. The important thing here with inequalities is to understand how to work with these signs. That's all. Excuse me. Okay, guys, we're done with the inequalities, and that was lecture number 4 of the equation playlist series. I am now going to lecture number 5, where I'll be doing exponential and log equations. We'll be solving both of them. I'll show you exponential equation and log equation. Thereafter, I'm going to close with simultaneous equation on the 6th lecture. Lecture number 6 is going to be simultaneous equations. On the simultaneous equations, we are going to do both methods, the elimination and substitution method. Alright, guys, we've done a lot of work so far, quite a lot, and I hope you're following it.